In this video, we are going to talk about drawing Lewis structures for different molecules. But before that, I would like to review a rule from general chemistry book, which we call that octet rule. So what does octet mean? The main group elements have the tendency to make a bond with other atoms in a way that each atom has 8 electrons in its valence shell, which gives the electron configuration of noble gas to that element and makes that element more stable. So if you look at oxygen here, oxygen has 2, 4, 6, 8 electrons around it. This carbon also has 2, 4, 6, 8. This carbon has 2, 4, 6, 8. So that makes the molecule very stable. There are some exceptions with the octet rule. The first one is that hydrogen and helium, they can only take 2 electrons. So we call them, they can get duet instead of octet. Next one is boron. Boron is in group 3. It has 3 valence electrons and it's happy with 3 bonds. So if we count, it can take 2, 4, 6 electrons around itself. We talked about tetravalent carbon. Tetravalent carbon has 4 bonds and it is happy, it is octet. However, trivalent carbon, positively charged and in the radical format, they are not following the octet rule. So the carbocation, positively charged carbon, has 6 electrons around itself and carbon radical has 7 electrons. And there are some atoms in row 3 and beyond that they are not following the octet rule. So if you look at sulfur fluoride here, the sulfur has 2, 4, 6, 8, 10, 12 electrons around itself. So they are not following the octet rule. How do we draw Lewis structures for different molecules? There are a few steps, 6 steps, that we need to follow while drawing Lewis structures. These steps are a little bit different from what is explained in your textbook. I believe this one is more comprehensive, so you can use it while drawing more complex molecules. And I'm going to explain them by drawing the Lewis structure for acetonitrile. To draw the Lewis structure for acetonitrile or any other molecules, we need to first calculate the number of, use a better color, calculate number of valence electrons. So in acetonitrile we have 2 carbons. Carbon is in group 4, so it has 4 valence electrons. We have 8 valence electrons for carbons. Nitrogen is in group 5, so it has 5 valence electrons, 1 of that. And then we have hydrogens. Hydrogen is in group 1, so it has 1 valence electron, 3 of that, 3 valence electrons. Now if we add up these numbers together, we are going to have 16 valence electrons for acetonitrile. Then the second step is to attach the atoms in the correct order using single bond. And be careful not to give more than 4 bonds to each atom, and also hydrogen can only take 1 bond. So when we read through the formula that is written here, we have CH3CN. So the first atom is carbon. Alright. After that we have H3. We know that neutral carbon can make 4 bonds. So I can put these 3 hydrogens connected to carbon, and then we have CN. So the second carbon can be connected to the first carbon, and we have nitrogen, which can be connected to the second carbon. Okay, so by reading through this molecular formula, I can come up with this structure. Then what we need to do is to find number of electrons used in single bond and calculate number of remaining electrons. So I know that each bond can take 2 electrons. I used 1, 2, 3, 4, 5. So overall 10 electrons were used out of 16 valence electrons that we calculated. So 10 electrons for bonds gives me 6 remaining electrons. Okay. After that, what you need to do, you need to put remaining electrons on heteroatoms. And heteroatoms are atoms other than hydrogen and carbons. So we put these remaining electrons on heteroatoms to make them octet. So my heteroatom here is nitrogen. So I need to put remaining electrons on nitrogen first. Do not exceed octet. So 6 remaining electrons. I use 2, 4, 6. That's it. Nitrogen is octet. Then what you need to do is, if any atom has less than octet, move lone pairs from its neighbor to make bonds. Okay, to make the other atoms octet as well. So if you look here, nitrogen has 2, 4, 6, 8 electrons. It is happy. This carbon has 2, 4, 6, 8 electrons. That's good. We know that hydrogens can only take 2. They get duet. Now if you count for this carbon has 2, 4. So it lacks electrons. Therefore, nitrogen is nice enough to share this pair of electrons with carbon. Now you can count again. Nitrogen has 8. This carbon now has 6. So again, nitrogen is generous enough to share another pair with carbon. All right? So after doing this, what you need to do, you need to check octet or duet for all atoms, which we did, and check the total electrons and compare them with the calculated valence electrons. So let me redraw this structure, something that we came up with. This is the structure that we have. Now if we count all the electrons in this molecule, we have 2, 4, 6, 8, 10, 12, 14, 16, which matches the calculated valence electrons. Okay. The last step, which is very important step, sometimes you may forget it, but always remember to check or calculate formal charges. Now to calculate formal charge, we have a formula. Okay. So formal charge equals to the number of valence electrons minus number of bonds to that atom minus number of electrons in the lone pair, or you can say number of dots. All right, so we can calculate the formal charge for all the atoms in the molecule. Let's do it together. Just number that as carbon number 1, and this is carbon number 2. So for carbon number 1, the formal charge would be, carbon is in group 4, so it has 4 valence electrons. The bonds around it, we have 1, 2, 3, 4. And the number of dots or electrons around it, it's 0. It doesn't have any electrons on it, which gives me 0 formal charge. The formal charge for carbon 2, again carbon is in group 4. It has 4 bonds attached to it, 1, 2, 3, 4, and 0 electrons. So that one is also 0. And the formal charge for nitrogen, nitrogen is in group 5. It has 3 bonds connected to that, minus number of electrons in the lone pair or number of dots. So I can see 2 dots here, which gives me 0. So the overall formal charge, if we add up all of these numbers, is 0, which matches the charge on the molecule. I can't see any charge on the molecule, which means 0, so it matches. This is how we draw the Lewis structure for a single molecule. Previously, we talked about a common bonding pattern in carbon, nitrogen, oxygen, and halogens. So we know that neutral carbon has 4 bonds, neutral nitrogen has 4 bonds and a lone pair on it. Neutral oxygen is divalent and 2 lone pairs on it. And neutral halogen is monovalent and has 3 pairs of electrons on it. Now let's see what will happen if we have tetravalent nitrogen. So an example for that could be ammonia. Ammonia is nitrogen connected to 4 hydrogens. Okay. So if we calculate the formal charge for the nitrogen here, nitrogen is in group 5. It has 4 bonds around it and 0 dots or electrons. So which gives me plus 1 charge, meaning that the tetravalent nitrogen is always positively charged. So in the same manner, you can draw Lewis structure for trivalent carbon or even divalent nitrogen or trivalent oxygen and see what happens. So I already did that for you. let's look at the carbon. So carbon in the neutral format, we already talked about it, is tetravalent and it has 0 formal charge. However, we can have trivalent carbon in 3 different formats. It can be neutral, which we call that radical carbon, and radical carbon has 2, 4, 6, 7 electrons. It can be positively charged, which we call that carbocation, and carbocation has only 6 electrons, so it doesn't follow the octet rule, same as radical. And the carbon can be negatively charged. The trivalent carbon, negatively charged, we call that carboanion, and it has 2, 4, 6, and also a lone pair of electrons on it, so it is octet. All right. We already talked about tetravalent nitrogen. So tetravalent nitrogen is positively charged. We can also have divalent nitrogen. So when nitrogen has 2 bonds, it should have 2 lone pairs of electrons on it, and it is negatively charged. You can calculate the formal charge for that, which should be -1. We can also have trivalent oxygen. So we know that neutral oxygen is divalent, and it has 2 lone pairs of electrons on it. Now trivalent oxygen has 3 bonds and 1 lone pair of electrons on it, and it is positively charged. Monovalent oxygen has only 1 bond and it has 3 lone pairs of electrons on it, and it is always negatively charged. So it is very nice if you get yourself familiar with these patterns, because you are going to see them a lot in organic chemistry and while drawing different molecular structures. It is really important that we distinguish between formal charge versus electron deficiency. An atom is electron deficient when it lacks electrons and it is not octet. However, an atom has formal charge when the number of valence electrons formally located on that atom is different from the number of valence electrons in that neutral atom. So what does that mean? If you look at the structure of ammonia, NH3, and the structure of ammonium, NH4 plus, okay. So if you compare these two structures, in both of them, nitrogen has its own octet. So 2, 4, 6, 8, 2, 4, 6, 8, meaning that nitrogen is not electron deficient, okay? It's actually electron sufficient. Now, why nitrogen gets positive charge here? That means the number of electrons located at the center of nitrogen, formally located here, is 1 less than the number of valence electrons in the neutral nitrogen atom. So the neutral nitrogen atom, nitrogen is in group 5, so it has 5 valence electrons. Now we have 4 electrons at the center of nitrogen here, so it gets the positive charge. Another important thing is that this should not skew your thought about the bond polarity and nitrogen being more electronegative than hydrogen. So what I mean with that is sometimes when you see the plus charge, you may think that nitrogen is less electronegative than hydrogen, which is absolutely incorrect, okay? Nitrogen, we learned that from general chemistry, is always more electronegative than hydrogen. NH bond is a polar bond in a way that nitrogen is more electronegative, and this plus charge should not mislead you. We have a few practice problems here. Let's calculate the formal charge for the following compound. Okay, so the first one, I number the carbon. This is carbon number 1 and 2, and we know the oxygen. We usually don't calculate the formal charge for hydrogens. We know that hydrogens get wet and they don't get any formal charge. So for the carbon 1 formal charge, carbon is in group 4. Let me write the formula first. Valence bond minus number of bonds and minus number of dots. So carbon 1 is in group 4. It has 4 bonds around it, minus 0 dots on the carbon, so which is 0. Now formal charge for carbon 2. Again, carbon is in group 4, 4 valence electrons. It has 1, 2, 3, 4 bonds around it, and again 0 dots, so it gets 0 formal charge. And for oxygen, oxygen is in group 6. We have 1, 2, 3 dots around it, minus 2 lone pairs, so 2 dots, which gives us plus 1 charge. So oxygen is positively charged here, which we expect. So we just reviewed that oxygen with 3 bonds, trivalent oxygen with a lone pair of electrons, it's always positively charged. Now let's calculate the formal charge for chlorine in this one. Chlorine is in group 7. It has 1 bond and it has 6 dots around it, so it should be 0. And this is again what we expected. Monovalent halogen, it is always neutral. When we are dealing with drawing Lewis structures for charged molecules, we need to follow the similar steps, the 6 steps that we just talked about. However, when we are counting the number of valence electrons, if we have negative ion, we need to add electrons to that number, and if we have positive ions, we need to subtract the electrons from that calculated number. So let's try to draw the Lewis structure for NH2-. First step, we need to calculate the number of valence electrons. So nitrogen is in group 5. It has 5 valence electrons. Hydrogen is in group 1, so we have 2 of that. Therefore, we have 2 valence electrons, and we have a negative 1 charge, so I'm adding that negative 1 to this calculated number, which gives me 8 valence electrons. Then the next step is connecting the atoms together. I have NH2, so nitrogen and 2 hydrogens around it. Then I need to calculate the number of electrons that are used in the single bond. So I drew 2 single bonds. Therefore 8 minus, each bond has 2 electrons, 8 minus 4 gives me 4 remaining electrons. Then I need to put these remaining electrons on a heteroatom, and basically I have nitrogen here that can take these electrons, and I put them on it. Then we check the octet, so hydrogen gets duet, we know that, and nitrogen has octet. Alright, and at last we need to calculate the formal charge. So the formal charge for nitrogen is the number of valence electrons, 5, minus number of bonds, it has 2 bonds, and minus the number of dots, which is 4. Okay, and that gives me the negative 1 charge. So nitrogen gets the negative 1 charge. And this is what we actually talked about. We have divalent nitrogen here with two lone pairs of electrons, so it is negatively charged.